Good morning, everybody. Today we are going to be talking about balancing equations. Now, this is another very basic chemistry skill, which is very important in everything that you're going to learn in the year 11-12 syllabus for chemistry. So hopefully you have an open mind going into this and are willing to put in the work now on the very basic stuff so that when you get to the more complex stuff, it's a lot easier. But anyway, let's get started. So balancing equations, we are going to do two examples today. It is actually a fairly easy process, but one of the main things that you do need to know before you can really get into this is what a chemical formula means. So if you are looking at this chemical formula here, you have 2 aluminiums and you have 3 sulfate molecules. So that is what that chemical formula means. That's very important because the whole point of balancing equations is that you have the same amount of molecules on the left-hand side, the reactants, as you do on the product side. So it's really important to understand what these things mean so that you can balance appropriately. I'm just going to rub this one out now. Excellent. All right, first thing we're going to do, real easy step, underneath the arrow, you are going to draw a line. Nice and simple. Then we are going to write down our elements or our molecules. So our OH and our SO4, we are going to combine together. Now, the only reason why you wouldn't be able to do that is if this exact thing doesn't appear on this side. In both of the examples we're using today, the SO4 is the same on the left side and the right side. It does not change, so we're going to treat it as the same as you would an element and just write it down together instead of trying to do everything separately because that confuses things. And we're writing it in order. So we've got sodium, our hydroxide molecule, aluminium, and then our sulfate molecule. So once you've done that, I typically just write it on the one side so I don't have to copy and paste it or use extra words. But if you want to make it a bit clearer, you can also have it on this side as well. So we're going to just quickly go through and write down how many of each thing do we have on each side. So we're going to start with our sodium. We have 1 on this side and 2 over here. Our hydroxides, we have 1 on this side, 3 on this side. Aluminium, we have 2 and 1. And sulfate, we have 3 and 1. All right, so this is a little bit of a complex start, mainly because I want to show you the process that I use and that it works no matter how complex the problem is. You just have to keep going at it. So let's get started. I always start from the top and work my way down because I find that a little bit easier and it gives me direction. You could probably look at this and say, you know what, if I started from the bottom and went up, it would be a bit easier. It's up to you how you decide to do it, but I'm going to go from the top. So firstly, we've got 1 sodium on this side and we have 2 sodiums on this side. So in order to balance out our molecules, I need to use numbers at the front. So I'm going to start by giving it a go and attempting to do 2 of those. So I'm going to cross out both the sodium and the hydroxide and say that I've now got 2 of them because the big numbers count for both of the things, both of the elements or the polyatomic ions behind it. So that means that the sodium is correct, but our hydroxide is not correct. So we need to have a look, have a quick look and say, all right, what can we do for the hydroxide? So the hydroxide over here, there are 3 of them. So we cannot multiply by a number that's going to make this equal to 2. So we are going to do the next best thing, and we're going to multiply the entire thing by 2. So now we're going to, I should be crossing those out. Actually, no, not the top one. So now, let's cross. We have 6 of these. So, and 2 of these ones. So now the aluminium is correct, but the sodium is now not correct either. So we need to go from 2 to 6 over this side. So instead of multiplying by 2, I'm going to change that. So we started with 1. So we need to get 6. So we're going to change it to 6, which means we'll have now 6 of these and 6 of these. All right, so now our aluminium and our hydroxide is both balanced. That's good. But our sulfate and our sodium is not balanced. So let's get the sodium first. So just chuck a 3 on the top there. So 3 times 2 is equal to 6. Which means that is now balanced. And we have 3 of these as well. So that is now balanced. So this process is just a bit of a back and forth. You go back and forth multiple times until you eventually end up with all of your numbers balanced. Now, like I said, if we did that whole process again, so if I go, come on, all the way back to the end. If you started from the bottom, if you had a quick look at this and you looked at the bottom one first, which is probably where I'd start normally, the sulfate, we've got 3 on this side, but only 1 on this side. So I'm going to start here by multiplying this by 3. So that's 3, 3, that's all good, which now gives us 6 for the top one, which means that we automatically need to multiply this one by 6 to give us this, and then this one by 2 to give us 6 and 2. So theoretically, that is a much easier way in terms of if you actually know what you're doing and you can pick out the one that's going to be the most helpful to you, that can be quite good. But like I said, I typically go from the top to bottom anyway because I find it useful to just have an order ready to go. Anyway, let's get started with the next one. So on this one, we're doing calcium phosphate plus lithium carbonate. So calcium phosphate, again, our phosphate over here and our phosphate over here are exactly the same as our carbonate molecules. Nothing has changed, so we can just treat them as one entity. So we got calcium, phosphorus, lithium, and carbonate. All right, so we have 3 calciums, 2 phosphates, 2 lithiums, and 1 carbonate. And then on this side, we have 1 calcium, 1 phosphate, 3 lithium, and 1 carbonate. Does that look correct? Yep. Okay, cool. So again, we are going to start from the top of the list. So we've got 3 on one side and we've got 1 on the other. So we're going to start by putting a 3 over here, which means we now have 3 of these and we have 3 of these. So this is now good. Next on our list is our phosphates. We have 2 reactants and 1 product. So we need to multiply this by 2, which is going to change this to 2 and this to 6. So now that is correct. And then next is lithium. So we've got 2 on the reactant side and 6 on the products. So we need to multiply that by 3, which gives us 6 and 3. So both of those are now correct. And now that is a fully balanced equation. So like I said, sometimes you get a more complex way going top to bottom. Sometimes you get a less complex version. But it is a very simple process. You just keep multiplying them together until you eventually get to a number that makes them all balanced. Now, the only last thing I really wanted to talk about, if you had, say, I'm just going to quickly rub these out. Okay, if you ended up with something like this, and I do often see people end up somewhere like this, where you've got really big numbers that are divisible. So instead of this number, the correct number would be 2, 1, 2, 1, because you're trying to get as small as you possibly can in these sorts of equations. So if you ever end up with something that every single number is divisible by something, whether it be 2 or 3 or usually it's 2s, you get it down to the smallest number possible. So like I said, that would end up being a 2 there, a 2 there, a 1 there, and a 1 there. Hopefully that made sense. It's just a couple of examples to hopefully give you an idea of how it works. If you'd like to see more, don't forget to leave a comment, and hopefully everything just made sense. I shall see you in the next video. Bye.